Hello, chemistry students. Today we are going to talk about balancing chemical equations. As a little review, you had this slide in the last video. We have reactants, which react together to form products. And here's an example. Iron plus oxygen react to form iron 3 oxide. Now let's break down some of the symbols you'll see in chemical equations. So the first one I'm going to point out is the plus sign. So this separates two reactants or two products. We have one of them right here. So you know that iron is separate from oxygen because there's a plus sign in this formula. Next, we have the arrow. This means that something is being formed, produced, or you could say yields when you're reading it aloud. And that separates the reactants from the products. Sometimes you will see a double arrow instead of the yield arrow. And this just means that it is a reversible reaction. So if you change the temperature or the concentration or the pressure of the surroundings, the reaction could be pushed the other direction. So S represents solid, so this is telling you that iron is a solid. G is a gas, so a solid reacts with a gas, and in this situation forms another solid. You also have an L, which would represent a liquid. And finally, there's another state, which represents an aqueous solution. So it just means that something is dissolved in water. Okay, so the first step in writing a balanced equation is knowing how to write a skeleton equation. Step one is to write the correct formula for each substance in the reaction, so the correct molecular formula. In this case, our reactants are sodium hydrogen carbonate and hydrochloric acid. So I will write the correct formula for each substance. I do not expect you to have hydrogen carbonate's formula memorized, but you should have your list of common polyatomic ions from semester 1. That's where you can find that information. Okay, so there's sodium hydrogen carbonate, and it's reacting with hydrochloric acid. Now our products are sodium chloride, water, and carbon dioxide. Okay, so there's step one. Indicate the state of each substance. So we have a solid, I'm going to use a different color for that. A solid, this is aqueous solution, aqueous, liquid, and a gas. Okay, we're going to separate the reactants and the products with an arrow. And we're going to use a plus sign to separate the reactants and products from each other. All right, so that's step one. That is how you write a skeleton equation. And then you can move on to balancing your skeleton equation. So the premise of a balanced chemical equation is that there can be no missing atoms. If you remember at the very beginning of first semester, we talked about the law of conservation of mass. So in any physical change or chemical reaction, mass is conserved. Mass can neither be created or destroyed. Keeping that in mind, what is wrong with the following equation? So if you notice in this equation, we are missing an oxygen atom. We have 2 hydrogens on each side of the arrow, but only 1 oxygen on the right, while we had 2 on the left. So this equation is unbalanced. A balanced equation is a chemical equation in which each side of the equation has the same number of atoms of each element. So in order to balance chemical equations, which I will expect every equation from here on out to be balanced, we will be adding coefficients. A coefficient is a number in front of a product or reactant. Okay, so when I'm balancing equations, I like to keep a tally. So when I begin my tally, I list out the atoms. There is hydrogen and oxygen on both sides. And then I write down the initial amount of each atom. So there are 2 hydrogens and 2 oxygens on the left side, and on the right side, we have 2 hydrogens and 1 oxygen. So it's really easy to see right here where the issue is. And now I add my coefficient. And as I add coefficients, I change my tally. Okay, so what we need to do is increase the oxygen. I'm going to add a 2 in front. So now we will have 2 oxygens, but it also changes our number of hydrogens to 4. So in order to balance that out, I will also need to put a 2 in front of our hydrogen gas. Okay, so there you go. This is a balanced equation after adding the coefficients in front. And I'd like to make a note about what those coefficients actually mean. That is a molar ratio. So when I'm reading this equation, I see that it takes 2 moles of hydrogen gas that react with 1 mole of oxygen gas to form 2 moles of water. Okay, we never use a 1 as a coefficient. If the coefficient is 1, then you just leave it blank. Okay? Okay, so this equation involves carbon and oxygen. We began with 1 carbon and 2 oxygens, and then 1 of each on the reactant side. So we will need to add a coefficient of 2 over here, which will change both of these numbers. And then add a 2 here. All right, so now there are the same number of atoms on both the products and the reactant side of the equation. This is a balanced equation. In this equation, we have magnesium, silver, nitrogen, and oxygen. Okay, let's take our initial tally. One each metal, 1 nitrogen, and 3 oxygens. And on this side, we have 1 of each metal, 2 nitrogens, because this subscript, 2 nitrogens, and 6 oxygens. So let's start by balancing our oxygens and nitrogens by adding a 2 in front of silver nitrate. So that will change all of these, and now we're balanced almost everywhere except for our silver. And that's an easy one to fix because it's all by itself. We just add a 2 in front, and now it's balanced. In this reaction, we have carbon, oxygen, and iron. One carbon, the products have 4 oxygens and 2 iron. 1 carbon, 2 oxygens, and 1 iron. Let's start on the reactant side by increasing our number of oxygens. So this will change our carbon to 2 and our oxygen to 4. So now we need to put a 2 in front of carbon monoxide. And that will change the number of oxygens we have to 5. So those are not the right coefficients. In order to balance the carbons and oxygens, let's just try going up by 1. So let's cross out 2 and add in a different color. Let's try 3 instead. So when we do that, it gives 3 carbons and 6 oxygen. Do the same over here. That gives 3 carbons, and then 3 plus 3, that gives 6 oxygen. Awesome. And now the only thing left is to balance our iron. I save the ones that are by themselves for last because then you know exactly what number you need to put in front of it. Okay, so we're going to change that. And now we have a balanced equation. There's 3 carbons on both sides, 6 oxygens on both sides, and 2 irons. Okay, now that you've seen a couple of examples, I'm going to actually ask you to balance this one yourself and then watch my answer. Okay, so it looks like this is mostly balanced. The only thing that's unbalanced is the chlorine. And there are 6 chlorine in the reactants and only 2 in the products. But chlorine is by itself in the products. So all you have to do is add a 3 in front of chlorine, which will change the number of atoms to 6. There you go. That's a balanced equation.